All right. Hello, everybody. My name is Desiree. I've kind of popped in as a surprise guest. I'm kind of getting the feel for video training. I've been a Cisco instructor for a few years. I specialize in CCNA, CCNP for routing and switching, and also some of the data center classes. And Ryan decided to let me pop in on the video today just for maybe 5 or 10 minutes. So for those of you that might be going, who's this new person that decided to pop in? I'll just kind of be getting a feel for the video environment for a couple minutes. So looks like about 3 of you have finished your evals. For those of you that might still be working, maybe you can multitask, listen to the next couple slides and topics while you're completing your evals. So this next section, we are going to be talking about managing devices. And when we look at managing devices, essentially we kind of need to take a high-level overview of our Cisco hardware in general. So when we look at, in particular, a router, we can see from this diagram that we're going to have things such as our flash, our NVRAM. Those particular items are going to be considered non-volatile. So anytime we're reloading our router, that particular information is going to remain persistent. That's then going to be able to communicate with some of the other mechanisms within our router, such as our CPU and our system control, which gives us the ability to communicate with our serial connections and our fast Ethernet connections. Earlier in your CCNA studies, you probably talked a lot about things like your console port. You're going to be using that for your initial configuration. Outside of that, we also have RAM. Now, keep in mind, when we look at RAM, RAM is usually going to be non-volatile. So when we look at RAM, essentially that's going to be where our running configuration is stored. So anytime we make any sort of changes to our router, it's going to be stored in RAM. We have to make sure we do that copy run start in order to save that to our NVRAM. Now, there are some additional components that we're going to look at in this section. One of them that actually wasn't listed on the previous slide is ROM. Now, when we look at ROM, ROM is actually going to be used at initial startup. This is where bootstrap, post, ROM-mon is processed. So ROM contains microcode. Our microcode is just broken into these 3 partitions. So when we fire up that router for the very first time, or if we're doing a reload, what happens is this ROM mechanism begins to run a series of steps. Those series of steps are actually displayed here. This is our power on boot sequence. So first and foremost, first 2 steps here are post and our bootstrap. These originate from that ROM partition within our router. So the post, which is our power on self-test mechanism, actually tests specific pieces of hardware to make sure that we have all of the components needed to actually be up and running. So let's say, for example, we had some hardware failures that would be detected in that post stage. Also, for those of you that are studying for the exam, make sure you highlight this page. You will need to know these particular steps. Another mechanism, our bootstrap. This is actually going to be used for things such as loading the bootstrap mechanism, which looks at where is our iOS stored. So remember, our iOS is the operating system that resides on our hardware, just like our laptops have an operating system on it so that we can interact with it. Just same thing, our routers also need an operating system so that we can interact with it. Now, when we look at that bootstrap is also going to look at something called the configuration register. We're going to look at that on the next couple slides. We can actually change that configuration register so that we can tell the router, hey, I want you to look at this particular piece of hardware for the operating system, such as flash. Or maybe we want you to boot into ROM-mon, which is a very low-level operating system that we might use for troubleshooting. We also have our iOS software, so once that's loaded, then we have the capability to begin to enter our commands, make configuration changes. And our configuration itself is stored in that MVRAM, or we can also store that and bring that in from something such as a TFTP server. All right, the next topic we're going to take a look at is that configuration register. Now, the configuration register is kind of neat because essentially what we're going to be looking at is having the ability to provision within iOS a specific field and a specific number in a particular field to say, hey router, I want you to look at the flash for the iOS. So let's look at a couple examples of how we would determine what our configuration register currently is set to and how we could change it. So we see a couple examples of that listed here. So our show version, this is our command that we can use to not just view things like our configuration register, but also what version of code are we running. So if we have some maybe older pieces of hardware on our network that's still running 14 version of code and we need to upgrade it, we can do the show version command to see what version it's currently running and which items need to be updated. Once we verified from the show version what our configuration register is, here they're displaying for us the 2102. That is the default configuration register. We can go in and use that config reg or config register command in order to change that. Now, you don't really have to memorize all of the configuration registers that are commonly used. The nice thing about our technology today is we can go to Google and find that information. So if, let's say, you need to do password recovery on a particular router and you want to bypass any of the configuration that's previously been stored, we can change that configuration register to ignore any previous configuration. We can change that password, save it, change the configuration register, and then reload that device. So just a couple examples of when we might actually use this. In addition to changing the configuration register, we also need to make sure that that change doesn't take effect until reboot. So we want to save it. They're showing us that copy run start command. Once you've reloaded that server, you issue the show version command. You'll then be able to see that new version being displayed. All right, I think what I'm going to do now is I'm going to pass the microphone back on over to Ryan so that he can finish up this section for you. Thank you so much for having me.
Alrighty, just give you guys a little bit of a change of pace there. Desiree's going to be teaching some classes in the future, so just wanted to kind of go back and forth and show her the format. Reggie says, thank you, well done. All right. So that was locating the iOS image files. Typically, when you look at iOS, it's going to be stored in Flash, but I've actually had routers before at customer sites where there was enough RAM to run the operating system, but not enough Flash. When you go to Cisco's site and you want to download a new version of code, you'll notice that there's system requirements. Not everybody reads those, and if you don't read them, that can get you into trouble, because what can happen is you can download an operating system, new version of iOS, it's going to be a bin file, and we go to copy it into Flash, and they go, there's not enough room. You look at Flash, and you go, oh, that's because the existing iOS is in Flash, so you can delete it. How weird is that you can delete the operating system while the operating system is actually running? Like, I couldn't imagine doing that with Windows or Linux, but what happens when you boot a router is that that bin file is actually a compressed image, and it takes the compressed file, kind of like a zip, and it extracts all the smaller files, and it loads them into memory. So what you have in the operating system is basically just a zip file. All the important files are in memory, so long as the router is running. What you can actually do is delete the bin file from Flash, and you can replace it with a new bin file. This is going to be fine so long as the router doesn't go out of power while you are sitting there with no operating system in Flash. Is everybody with me? We made a couple jumps in that story. Just want to make sure everybody's following. Okay, I probably could have explained that a little bit more eloquently, but we got lots of thumbs up. You guys are following me. Okay, great. So one of the things I did previously was at a customer site, operating system's running, and go, oh, you want these features, you want to grab this new version of code, let's go ahead and download it. Try to upload it, we're out of space, you delete the bin file that's in memory. which gave me some more space. I go to copy the file in, and I just wasn't paying attention. When I looked at the show version output, I saw that it had, like, let's say 256 megs of RAM, and it had maybe 32 megs of flash where it needed 64 because I had, let's say, a 40 meg image. So I went to copy the new OS in, and there was no room for it. Now I start sweating. I just have to go to Cisco's site, and I need to find the appropriate OS, but I'm going, man, I hope the power doesn't go out while I'm in this process, right? So fortunately, the router was on a UPS. Fortunately, even though this is Florida and we've got unpredictable thunderstorms, none rolled up and surprised me, and I was able to go back out to Cisco's site, download the appropriate version of code, and then push it to the router. Now, one of the weird things that Cisco will do is they'll remove software from their website. So you could go there today and download something. Don't assume that it's going to be there when you go back. I ran into this earlier this week, trying to show some students some of the features with the clientless SSL VPN on ASAs. It requires these special Java files, and because a Java update broke them, Cisco removed those. Additionally, we've got UCS server hardware here, where it needs a particular version of code to do an update, but that version of code, let's say that it's on 1.0 and it wants 1.1 before it gets to 1.2, 1.1 is no longer available. So the moral of the story is what would have been a better idea is when I went to replace the operating system, I should have backed up the older bin file on a TFTP server, then deleted it, and then copied the new one in so that I always had it handy. So a little bit of a long story there, but I have had some pain when dealing with iOS files, so I just wanted my experiences and my pain to maybe save you a little bit of trouble. So just things to keep in mind when working with those image files. Whenever you boot the operating system, one of the things that you'll see happens is right here. It says self-decompressing the image. It's taking that bin file, extracting all the components, and putting it into memory. And this is not the fastest process you've ever seen. For those of you that might have used GNS3, what we do with GNS3 is we extract all the files inside of the bin, and that's why when I load routers in GNS3, they load immediately. So just realize that that image gets decompressed each time you load. Let's see, Reggie says, is there a way to re-upload the iOS if the router does lose power with no bin? Absolutely. If your router, now I'm going to give you some spoilers if I answer that right now, but basically what happens is there's a pre-boot environment that we called ROMmon or ROM monitor, and it's kind of like iOS, but it's not quite as helpful. Like you've got the question mark and you can see some commands there, but it feels like a computer interface from 20 years ago. It looks, and it's a little, I don't know, it's not the most pleasant environment to work in, but it's not too terrible. And what we can do from ROMmon is perform procedures like password recovery or recover the operating system if the power went out. It would have just been a little bit ugly because the router would be there and it's functioning from a console port perspective, but we don't have our operating system, we don't have routing protocols, and basically that site would be offline right now. And if I didn't have a local copy of iOS backed up, I have to go somewhere else that has a good working internet connection and download the file. Now, 5-10 years ago, that might have been an issue. Today, I would just use my laptop, tether through my cell phone, grab it over the 4G, hoping, crossing my finger and hoping that I've got a good 4G signal, and then I could just upload that file to the router. Good question. Okay, so when we load iOS, as I mentioned before, you decompress a bin file, loads lots of little files into memory, and that's where your operating system actually runs from. So what else do we have? If you do a show version, it shows us some cool stuff. It shows us the platform that we're on. In this case, it's a 2900. Shows us the file type. In older versions of iOS, you had different file types for different types of features. There was an IP-based feature set, there was an enterprise services, you had a security build, you had a service provider build, and so forth. So we can see here in version 15 and higher that the version of iOS that we run is universal. What that means is that you don't have to download particular files like a security build or an enterprise services build. You basically have all the features in one file, and then we can just activate the features with the license file. We'll talk about licensing a bit at the end. Additionally, we can see the actual image file. So this is the bin file that was loaded when the router boots. If you continue to scroll down through that show version output, we can see some of the hardware capabilities. In this case, a count of the number of interfaces. We've got 2 gig and 1 serial. Here we see the amount of NVRAM The non-volatile RAM is going to be used for storing certain files. We're going to talk about that in a little bit. We've also got RAM, which is our memory, and you also have compact flash here. Compact flash is kind of like the hard drive for the router. This is where we store the operating system. This is where we can store additional backups of configuration files, and we might even have backups of other versions of the operating system, depending on how much compact flash we have. The memory itself is what we look at when we think of RAM. So just make sure that you're looking at the right lines and interpreting them correctly. And additionally, here's that configuration register, and we can view that from the show version as well. You can also see the uptime of the device. Whenever the device loads, it executes the configuration file that's stored in NVRAM. So we talked about this a little bit before. We said whenever you make changes to the router, those changes occur in the running config. And if the power was to go out or the router reboots, we're going to lose all of our changes. So what we do is we copy the config that's running, that's what's in memory, to the NVRAM. And the command for that, of course, is copy running config, startup config. So it says take what's in RAM and copy it to NVRAM, or non-volatile RAM. If you think about the term volatile, it just means we can't trust it. It could go away at any time. So what happens there is the NVRAM is not compact flash, but it's pretty similar. It's just a small area of basically flash memory, but it's a separate partition that we can store certain data in. The data that we're talking about right now is our startup config. So whenever the router boots, based on what the configuration register says, we're going to load the operating system, and then once the operating system loads, we apply a configuration to it. So your configuration, that startup config, actually gets pushed in every time the router boots. All right. So what are they showing us here? The router boots and loads the operating system. Based on the config reg, we go, is there a startup config in NVRAM? If so, we load it. If not, is there another active link to a router? And if there is, we can try to load a configuration remotely from a TFTP server. This isn't a typical behavior that we want to do, but it's something that you can do. So we could remotely pull down a configuration file. If he can't find a configuration file anywhere else, he can drop into Raman. So let's see. This isn't really accurate. I was like, wait a minute. So let's run through this and let's talk about some of the confusion that's in this slide. When the router boots up, let's talk about this. Is there a configuration found in NVRAM? Yes, load the startup config. My question is, where's the operating system? So it's more of like this. The router boots up, it does a power on self-test. If the power on self-test passes, we check the config reg. If the config reg tells us to, we look in Flash to load the operating system. If we see a bin file, we go ahead and load it. That would be the yes, load the operating system. If we do not see an operating system, that's where we go into Raman. This is a pre-boot environment where we can basically recover the device. That is for the operating system. This slide is supposed to be about loading iOS configuration files. So if your iOS configuration file fails to load, we do not go to Raman. Can anybody tell me what happens if the startup config is missing? For instance, if I log into a router and I say write erase, and I say yes to verify, and I reload the device, what will happen? It'll reload, it'll load the operating system, and when the router or switch or even a firewall sees it's nothing there, perfect, Gavin, you're going to get the default configuration, which is pretty empty. If it's a router, it'll have a host name of router with all the interfaces shut. If it's a switch, you're going to have a host name of switch with all of your interfaces in VLAN 1. What it'll do when it sees that is it'll actually push you into a setup script. So that's what I would say here, setup script. Good deal. So looking at your different configuration files, you can do a show running config. This is what's in RAM. And you can do a show startup config. This is what's in NVRAM. One of the things that I'll do is sometimes I make mistakes, like we all do. And let's say that I'm in a switch. We'll pull up switch up real quick. And if you were in IC&D with me once and I showed you this, I apologize for reusing the same story, but it's something that happens to me from time to time. I'm looking at the documentation and I go, okay, I'm gonna go ahead and configure interface gig 10/16. So you go conf t interface gig 1/0/16. And maybe I mistype the 16 and I put 15. If anybody's ever misconfigured an IP address, it's the same thing. So maybe I say default interface 15, and it goes, all right, reset to the default, and I go, crap, I meant 16. What can I do at this point? I'm starting to panic. I don't have any backups. I'm not sure what was on port 15 before I erased it. If I say show running config, int gig 1/0/15, it doesn't have anything. But if I say show startup config, can I do interface? I don't think so. No. But I can do a show startup config, and I can do pipe begin 1/0/15. And look at this. I can see what was on port 15 before I erased the wrong interface. Did everybody follow that? So your startup config is a safe config at NVRAM. You can view it at any time, and that can be useful if you make a change in the wrong place, or if you do make a change and you just want to see a good copy of before and after. A better practice than relying on that is before you make a change, and this is what I do at customer sites, as soon as I sit down on the router, I say copy the running config to 09/11/2014.cfg. That's the first thing I do. Now that configuration file is not in NVRAM, but it's in Flash. If I type dir, I can see this from different days that I've built configurations? You see the date that it was changed in the CFG file. So before I do anything to the router, I've got a copy there. Another thing that I've talked to engineers that they like to do is they like to turn on logging in PuTTY. If you turn on logging in PuTTY, it logs everything that you do, so you can go back through your logs and carve things out if you needed to. So that can be handy as well. Other students have come through class and they've used an open source application called Rancid, R-A-N-C-I-D, and that's an application that can go out, log into your devices, pull the configurations back in, archive them, and then you can do diffs, which is just a differential comparison between two files, and we can see which changes were made when. So a couple different strategies for dealing with log files, configuration files, and if you don't follow any of them and you do make a mistake, just realize that you can look back to your startup config and you can get the configuration that was there before you made any changes. Your configurations are active in RAM, but if I wanted to fix port 15, it would be real easy. I could just scroll up here, grab the configuration that was on port 15 previously, and then just right-click to paste it in. And these are just warnings saying be careful with port fast. That's all. All right, so back to the show. That's our running config and startup config. As far as the file system and devices, anytime you use a command, like the copy command, you copy from somewhere to somewhere. In Cisco, it's almost always source and destination. Your source and destinations for working with the file system could be Flash, which is kind of like the router's hard drive. It could be RAM. It could be NVRAM. That's what happens when I do a write. It could be USB, and it could be a TFTP server. You could also pull things down from remote FTP servers. You could pull things down from HTTP. HTTP is read-only, it's not write. And just to show you real quick, anytime I do a copy, you can question mark, and these are the different services. So that slide wasn't entirely extensive. Like X or Y modem is to do a file transfer through a terminal session. So I could be consoled into the device, and while I'm consoled in, I could go ahead and transfer those files over. This is going to be really, really slow though. Some older equipment required you to do this. SCP is secure copy. This is moving a file over an SSH session. You can see here we can support FTP, HTTP, HTTPS, and so forth. So there's different systems that we can use for copying files back and forth. These are just some of the most common ones. If you do a show file systems, this displays all the file systems that the router is capable of addressing, and it shows their media. So for example, if you look at HTTP, this version can do read-write. Other things might be read-only. A lot of Cisco devices can read from an HTTP device, but they can't write to it. As far as managing our iOS images, we can copy from Flash to a TFTP server and copy from TFTP to Flash. You can also use the other mechanisms like FTP or secure copy if you needed to, but TFTP is probably the most common. As far as looking at these image file names, the first C2900 refers to the platform. This is a Cisco 2900 router. Universal means universal feature set. Whatever you want to do, whether it's MPLS or BGP or zone-based firewalls or Call Manager Express, all of those things are included. They just need to be turned on with a license. The file format is whether or not it runs in RAM. So when you see MZ, M means it runs in RAM, and the Z means it's a compressed file. Down here, we actually see the version. This should be version 15.2. And then the bin, this is just a bin file, but it's going to be a binary executable. We're going to go ahead and extract all the files out of this bin and load them into memory. As far as creating an iOS image backup, I can copy from Flash to a TFTP server. And this is what I was saying would have been a good first step before upgrading the iOS. I don't know that this version, which works fine right now, I don't know for positive that that's still available on Cisco's website unless I go there and check. So best case is just to go ahead and back this up in case I ever need it in the future. If I want to verify that I can reach the TFTP server, simple, I'll ping it. Additionally, if I want to see what's going on in Flash, I can say show Flash, or alternatively, on most Cisco devices, you can do dir, which is basically an alias for looking at your Flash. So these are all the details of what's in Flash. To do a copy, it's source and destination. So in this scenario, I say I want to copy a file from Flash to TFTP. They say, awesome. What file? And I go, that file. And they go, where are you sending it? And I say, this IP address. And they go, what do you want to name it when it gets there? And it'll use the same file unless you want to change it. So if I wanted to change it to a different name, I've got the ability to do so. As it performs the file transfer, it'll give you a bunch of exclamation marks to show you that progress has occurred. And then once it's completed, it gives you a notification as well. If I wanted to upgrade the operating system, I would typically go out to Cisco's website, download the latest version of the operating system, and place it inside of a TFTP server. This is just a service that you can run, and there's a number of TFTP servers available for Windows, Linux, OS X, and so forth. I make that available, and then I can copy it down by saying copy TFTP Flash. And that's all they're doing here. They're pinging to verify connectivity. They're using IPv6 just to be fancy. Again, you can do show Flash to view the contents of Flash. And what they're trying to draw your attention here to is how many bytes are available. You can see that it's listed in bytes, so it's not terribly difficult to miscount that and think that you have 10 times more space than you actually do. So just be careful when adding that up. As far as copying the file to our router, we say copy TFTP Flash. It goes, okay, who's the remote host? What's the file that you want? And what do you call it when it gets here? I try not to rename these because there's a method to the madness. Again, we can see the platform, we can see the type of image. K9 means it has a full crypto set, so it can do things like AES and SHA-1. M means runs in RAM, Z means it's encrypted. We see that this is 15.2 code, etc. Just as before, we've got exclamation marks for progress. And then what we can do, if you've got multiple versions of the operating system in Flash, it may not know which one to load. It's just going to load the first one in order of looking at your files. What I mean by that is when you do a dir, notice that each of these files has got a number in front of it. It's just going to take the bin file with the lowest image. I've only got one right now. But if you had multiple, you can tell it which file to load by using the boot system command. And you tell it which bin file to load at boot time. After we issue the command, you say copy run start, or you could use the shorthand version, which is write, and then reload. When we reload, it'll grab the new bin file and load that operating system into RAM. Anytime we do a copy run start, just to clarify, this is going to move contents from RAM to NVRAM. If you were to do a copy start run, you're going to get a merge. What does a merge mean? Can anybody help me out with that one? All right? No takers. Basically, perfect, Gavin, thanks. It's going to give you a mix of both configurations. That can be confusing. And let's see, Reggie says it will combine the two instead of overriding one. Right on. It's going to overwrite some fields and not others. So let's say username. I could have 100 usernames in my running config. I could have more than 100. But when it comes down to, let's say, my OSPF process, or let's just use the usernames. I've got 25 new usernames that are A through M in running config, but my startup config has got 24, let's say 25 more usernames that are N through Z. When I do copy startup to run, you get a merge, so I get a collection of total of 50 user accounts. So you get what was in the running config and what was in the startup config. The tricky thing is you'll sometimes get a merge. Not a merge, but let's say, let me clarify. When you merge, you'll sometimes get, instead of a collection or concatenation of data, you'll actually get an overwrite. So let's say that interface VLAN 10 had an IP address in the running config of 10.10.10.10, and my startup config, when I moved it in, it was 10.20.20.20, it would overwrite that IP address. So a merge will do a concatenation or a combination or summary of basically adding all of that line items together, and on other attributes or other settings, it'll actually overwrite it. Does that make sense? It's a little bit fishy to know exactly what you're going to get with that merge, which is why some people think it's a little cleaner to do a write erase, reload the router, and then copy the starting config into the running config just to make sure it's totally clean. All right. So, additionally, here's some examples of that. They've got the running config and the TFTP server, and they say copy TFTP run. Do you see, here's interface gig 0, but it was interface gig 01 that was overlapping. So that is going to become this. See how this was a 10.2.2 address before? So that was overwritten, and then previously we didn't have any interface on serial 0. Now we're going to obtain that. Doing a copy run to TFTP, this is going to back up our running config to the TFTP server. Once again, just asking for the IP address and now asking for the file name. Just as before, we'll get exclamation marks for successful data transfers, and it's going to let us know when we're done and how long it took. Additionally, we could do a copy of the TFTP to the running config, and it looks very similar. This time they're just using IPv6 addresses to demonstrate that you can do this over v6 as well. Password recovery, this is easier than you might imagine, and this is the reason we need to physically secure our routers. When the router first boots up, and it will say, well, it's already running. Well, I can walk into the server room and turn off the router, plug in my laptop and console cable to it, and turn it back on. As it's booting, there's a message that comes up that says, press the break key to enter Ramon. The hardest aspect of password recovery on a router or breaking into other people's routers is finding a break key on your laptop, especially if it's like a Mac. You might have to hit a special hotkey combination that would be equivalent to a break. But once we get that break in there, it's going to break out of loading the operating system, and it's going to drop you to Ramon, which has a prompt like this. We can use the config-reg command to set the configuration register to 2142. This is a special designation that says ignore the startup config. I'll put SC, but boot the operating system. So what happens is the OS loads, and it just loads with the default configuration. Once we load with that default configuration, what we're going to do is be looking at the switch, and it says hostname switch. I type enable, and it goes, okay, switch #. I'm like, all right, I'm the king of the kingdom. I'm in admin mode. Once I get to admin mode, now I say copy start to run. So it loads the configuration, and as it loads, I've already gained administrative access to the enable prompt or privilege mode. I'm basically sitting there at privilege level 15. Now that the configuration's there, I can overwrite the password. I'll say enable secret Cisco123, and I overwrite the password that was there with the Cisco123 password. Then I type write, and I put my configuration register back, and then I save it. The biggest mistake you can make with this whole process, it's easy to do password recovery, but it's also easy to forget to change the configuration register back. So what you'll do is you come over to your device, and when you're done fixing everything, you do a show version, and in your show version output, we can see the configuration register. A little bit different on this switch, and the configuration register will be a little bit different on each device. So what you'd want to do is say Cisco password recovery 3750X or Cisco password recovery 2921 and see what the password recovery steps are. And the main thing is that configuration register might be different on different types of hardware. All right. So again, just to step through the process, we set the configuration register, reset the router. When the router reboots, he sees this config reg and he says ignore the startup config but boot the OS. So basically, the router loads and puts you at the default host name. We type enable, and voila, we're at privilege level 15. Now that we're in exec mode, we can copy start to run. The problem is that previously, when I tried to go into enable mode, it would have locked me out because I didn't know the password. One of the things I need to do when I copy those that running config in is go ahead and do a no shut on my interfaces, make sure nothing is shut down, and then I can go into global config and I can set a new enable secret. So here they are putting the new password. Last but not least, we set the configuration register back to the default and save our configuration. And that's the password recovery. All right, so those are some of the major steps for setting up a router, including what Desiree covered, which is what happens when it boots. We'll go ahead and take our 15-minute break, and when we come back from the break, we'll do a real quick section on licensing, and that will wrap us up for the day. So I'll see you guys back in 15 minutes, or alternatively, if you just wanted to come back in 10, we could come back in 10. Just let me know in the room chat if 10 minutes is okay, and if it is, we'll come back. If you need the 15, let me know too, and we can take 15 minutes. Thanks, guys.